Hey, how is it going, everybody? Welcome to the YouTube channel of Petroleum from Scratch. I am Jaiyesh Chahar, and this is Statistics for Energy Engineers playlist. In this video, as I said earlier, we will be starting our discussion regarding the measure of central tendency. So, the first point that comes into picture that why should I measure the central tendency of data? So, what happens? You are given a problem statement, right? So, you have to design a solution for that. You will get the data in your initial stage. Now before moving on to some advanced steps or some fancy steps like machine learning algorithms, using machine learning algorithms or data cleaning and all those things, the first very important step that comes into picture is knowing of your data. If you know your data, if you spend more time with your data, you know whatever is happening or how your data is present. So the more you know your data, the easier it will become for you to deal with it, right? Similarly, as this is one of the saying of myself itself, that the more time you spend in the EDA part, exploratory data analysis part, the less you will bleed in your modeling part. So whenever machine learning modeling stage starts, you will have less trouble if you know your data properly. That's why a measure of central tendencies comes into picture. Basically it means that you know your data, right? You know at which point your central element of the data is present. So basically this particular thing, measure of central tendency, will give you summary in statistic that represent the central point of the data. Summary, okay, in statistics that gives you central point of the data. Central point of the data. So how to measure your central tendency of the data? So there are basically three things that you can use. Three basic things: either by mean, calculating the mean of the data, or median, and third one is mode. So these three are your measure of central tendencies: mean, median, and mode. And depending on your data and use case, we will be using these three only. So we will start our discussion with mean itself. So mean is basically your average of the data, as the name itself is representing simple mean, average of data. And how to find out this particular mean, again depending on that whether we are dealing with the sample data or population data, your formula notation for calculating mean will change. So if you remember from the last session, I told you that whenever we are talking about a population, right? So in population, the total number of elements present inside your population data is denoted by n, and the total number of sample or total number of elements present inside your samples data is denoted by small n, so capital N and small n. And now let's take an example that in my population x1, x2, x3, these till xn, these data are present in my population. Give me a second. So these data points are present inside my population, right? Let's just separate this out. So the formula for your mean, that is denoted by mu, will be your x1 plus x2 plus x3 up to so on till xn divided by n. So basically it will become nu or population mean. Population mean is denoted by this nu, right? Summation of your I from your 1 to n divided by n, your simple average formula. So mean is nothing but average of the data, right? I will highlight this particular formula so that it will easy for you to remember. Now coming to our samples part. Again in samples there will be data points x1, x2 till x small n, right? And for sample mean is denoted by x bar. So remember these particular notations because we are going to use these notations only moving forward. New for population mean, x bar for your sample mean, and formula will remain same, x2 till xn divided by small n. So your x bar equal to summation of xi I from 1 to small n till n, right? So this is your mean of a particular data. So let's take an example. Let's take an example that we have population data of ages of people, age of people. We have data of age of some people, right? And we have data, let's take 18, 20, 25, 26, 15, 10. So this is your population data. Actually, in population data, more data points will be present, but for making thing easier, I have just taken these many six numbers of ages only. So mean of this particular data set will be your just summation of all of them, 18 plus 20 plus 25 plus 26 plus 15 plus 10. This is your 10. No, 16. Let's make it 10. Divided by 6 because 6 number of data points are present, and it will come around approximate of 18, right? You have find your mean here. Now let's add an outlier here. So what is an outlier here? If you see basically the points, basically the numbers are in range 10 or 20s, right? Because 10 is present or 20s are present. But what will happen if I add a outlier here? Outlier basically means that is of some different range, even either a very high number or a very low number compared to all other numbers that are present inside a given data distribution. So for example, let us take these values same 25, 26, 15, 10, and let's add an outlier of 100 years old man age is also added in this. Now, if you will calculate this particular thing, mean of this as mean of above this data is 18. So I will just take 18 for first six numbers plus 100 divided by 7. So now you will see the mean will come around 29.71, right? By just adding one outlier, by just adding one outlier, my mean has changed insignificantly. Around 11 years of change in mean value of ages has happened, right? So mean changed very high by adding only one outlier. So now it is not giving me good central point, right? Because if you see this particular data, my maximum age was 26, unless I have added an outlier. And my mean is giving me central tendency that, okay, 29.71 will be central tendency of this data, which is actually not correct statement, right? Because 29.71 is around above 99 percentile of the data, having value above 99 percentile of the data. So for dealing with outliers, for dealing with these type of outliers, medians comes into picture. So median is nothing but your central point itself, central point present in the data. What does this mean? So how to calculate the median of this particular data, we will see with this example. So first of all, my first step will be the sorting of the values, sort the values. So I will be arranging the values in ascending order, starting from the lowest number and going till the highest number. So 10 will come first, then 15, then your 18, then 20, 25, 26, and 100. And as I said, median is my central point, right? So by default, what will be the median here? Just I have to go to the central point. So around 7 points are present, right? So three here and three here. These three points are there. My central point in the these seven numbers will be my fourth point, right? So this particular number 20 will be my median of the data. The data point that is present at the central point means 50% of the data is lesser than this point. Yes, 50% of the data is lesser than this point and 50% is more than this point. So in this way, you can calculate your median. Your central element will be the median. And here, if you see 20, 20 is kind of giving me more accurate estimate of central tendency of the data as compared to the median, as compared to the mean of 29.71, right? So when outliers are present, use median. When outliers are present, use median for a measure of your central tendency, right? For handling outliers in numerical values, we use median for calculating the central tendency. Now the third one is mode. Mode is basically the value that is repeating most number of times in the data. Value repeating most number of times. Highly frequent value in your data will be your mode. So this is basically used when we are dealing with your categorical data. For example, let's take an example of some lithologies. I have data of some lithologies. It is your salt, limestone, sandstone, shale, again limestone. So this is the data from your core samples, you can assume. Sandstone, again limestone, limestone. So here my mode will be limestone because limestone is repeating most number of times. Four samples from limestones are present, or you, instead of samples you can just say four times limestone is present in my population data. Population data. Four times limestone is present in my population data. So these three are your measure of central tendency. Mean and median are used for your numerical data, right? Calculating measuring the central point for your numerical data. And mode is used when we are dealing with your categorical data. In numerical data, you can also use, for example, in this age one only, if I add one more number 10 here, so 10 will be your mode in this because 10 is repeating most number of times, right? And one more thing in median, here odd number of points were present, right? That's why just taking the medium point or the central point, I am saying that is particular median. What if even number of points are present? For example, I added after 100, I added 200 also. So now these two will be my central points, right? Because three data is present here, number of data points are present here. So 20 and 25 are my central points. So I can just take average of these both, divide by 2. It is approximately 22.5, and this average will be my median value in the case of when even number of points are present inside your data, right? So in this way, these three central tendencies can be used. Let us plot let's plot some distributions also so that it will be easy. So there are basically three types of distribution. One is normal distribution, that again we will be discussing in detail in coming chapters or coming videos. And this is your right skewed distribution, having a long tail towards your right side. And this is your left skewed distribution, right skew, normal, and left skew. So basically on x-axis are your x points or data points that are present, and y-axis just assume that frequency of those points are present, how many times it is repeating or something, right? So for normal distribution, you can see this particular point, the highest peak is basically representing your mode because it is repeating most number of time, right? So in both these, this will be your mode. For normal also, this will be your mode. Most frequent number that is repeating. In normal distributions, what happen? Your mode, mean, and median are same point itself because 50% of data is at this side, because if you see these are just mirror images of each other, and 50% is this side. So median is also the same, and mean will also be the same in normal distribution. But what will happen in right skew? This will be your mode, and somewhat here your median will be present. And as I said, small outliers can affect your mode values, so mode will be present somewhere here. So for right skewed distribution, your mean, oh sorry, I have entered mode again, my mistake, it will be your mean. Your mean is greater than median, is greater than mode. For normal, mode equal to mean equal to median. And for the left skewed one, your mean will be somewhat here, your median will be somewhat here, this will be your median. So again, you can say that mode greater than median greater than mean. So these, in this way, depending on your distribution type, mean, median, mode value generally changes. One of the example for this right skewed distribution is wealth distribution. Wealth distribution among people across the world. So if you know that 90% of the wealth is owned by 10% of the people, so this right hand thing, that most number of wealth, only very less number of people are present if you see the frequency, but they are having most of the wealth. For example, if X is donating your wealth, so in this way you can say that wealth distribution is a right skewed distribution. Normal distribution generally, in nature, generally the all the datas, not all, 90% of the datas are present in normal distribution only. For example, your age distribution is a normal distribution, height distribution is also a normal distribution, your different type of machine parts, length of different type of machine parts is also a normal distribution. And in the left distribution, one of the example is death rate. So yeah, this was all about measure of central tendency. Second. So this was all about measure of central tendency. In the next video, we are going to discuss measure of dispersion, how much dispersed your data is. So until next time, have a good time. Happy learning. Bye bye. Take care.